So, the basics. Giving everybody a chance to read this. I don't like to just read what's on the screen. So, the entire purpose of MapReduce, scalability, fault tolerance at scale, right? Scalability. How far can you scale it? How many nodes? How much data? What size? What's the time that it takes? What's the tolerance to recover from a failure? If you run a query on Oracle and it takes 6 hours and it fails, what do you have to do? You have to rerun the whole query. If a single job that's a part of a whole bunch of jobs in MapReduce fail, what happens? The one job reruns, response comes back, very minimal failure time, fault recovery. The map and reduce functions, core, very simple, right? I want to read my data in, I want to figure out how I want to organize my data, I want to figure out how to aggregate that data, I want to output it, I want to look at my data. 9 times out of 10 from people that I know doing MapReduce, I know, again, 9 times out of 10, mappers only. Depends on who's doing the work, what they've got going on. But a lot of people, they just care about getting the data in and doing some types of transformations. So the flexibility is there, the speed is there at scale. So this will lead us into why does Spark really make a difference. The very bottom bullet point is kind of about the most important piece of Apache Hadoop in MapReduce. It is very heavily tunable. Would anyone here care to raise a hand and tell me if they've spent more than an hour on tweaking MapReduce jobs that they've written? Okay, at least a couple. So, besides the data, the total number of nodes, the distribution of your data across those nodes, how many CPUs you have, how much memory you have, where you want to balance this out is what you have to figure out in order to properly tune MapReduce jobs on Hadoop. Okay? So these are all things, they're very important. You don't get to just ignore them if you're going to go to a production environment with this. They're things that are going to matter to you because they're going to hit you at one point or another. With respect to how you do MapReduce, okay? It started out, it was pretty much all Java MapReduce. Scala came on the scenes, Clojure came on the scenes, Java-based, or Java runtime-based. Python and Ruby picked up a little bit of steam. The higher level languages, does anybody know why the higher level languages showed up? What was the real driving motivation behind these?
Because everyone hates writing MapReduce.
Right. So Pig is one of the more adaptable scenarios or examples for people who are programmers, which is procedural language. Okay. So very early on in my experience, I met one of the key people at Twitter, and he explained to me, we use Pig, and here's our examples that we have. And we wrote this in Java MapReduce. It was 200 to 300 lines of code, and here's 10 to 20 lines of code of Pig. Okay? From a productivity standpoint, you get a much faster iteration cycle to ask your questions, because at the end of the day, it comes down to what are your questions, what are the answers. Most of the time, what people find out is that they've asked the wrong question. So the best way to go about it is to make it so that you ask your questions faster. Right? The faster you can ask your question, the less time you waste when you get the wrong answer and have to go re-ask your question. Nobody wants to go write 200 lines of Java code, run it, see a completely wrong answer that they had no expectation of, and go back and rewrite 200 lines of Java code. Going and modifying 2 or 3 lines of Pig code, not too big of a deal. People don't stress out about it very much. So the frameworks Cascading and Crunch, when they showed up, this was really, in my mind, this is a big deal for MapReduce, because now it took a level of normalcy to the MapReduce pattern that was there, that Pig and Hive brought to the table, but where Hive and Pig kind of lack is how easy it really is to deliver user-defined functions in those languages. When you're in Cascading, you're using a framework to help put these things together. When you use Crunch, you're using a framework to put these things together. You get down to the DSLs, which finally bring all this together and deliver you something that you can say, oh, I want to do X, Y, and Z, and I want to now write my user-defined function, and you put it in the same spot where your code is. Because it's a functional programming language, the framework that they've built made it easy for people to be able to say, I don't have to go write a Java user-defined function and then go write my pig script to make it work. It just makes it easier. So using these frameworks is all about ease and reducing pain. So in the standard model, you've got your mappers, your data gets shuffled around, it goes to your reducers, you're good to go. Well, the entire reason for using something to create a pipeline is that it's more than just a single MapReduce job. Pig and Hive generate multiple MapReduce jobs based on the type of aggregations you're doing, how you want to group your data, how you want to sort it. It automatically generates the MapReduce jobs. So from a functional standpoint, you end up with multiple MapReduce jobs. If you're doing this in Java MapReduce, this becomes very painful. You do it in Pig and Hive, it hides it from you because it's such a strict pattern. So the DSLs have pushed MapReduce a long way. The DSLs, in my opinion, are what are getting more people to adopt utilizing Hadoop for data analytics. So where does it really stop? Well, this is where Spark comes in. So where the DSLs leave off is, in my opinion, where the technology like Spark really comes into play and allows you to go to that next level. And for the people that are, say, doing daily data analytics, they're asking lots of questions. You want to speed up their iteration cycle. So this is where Spark comes in. So quick little background on Spark. There's a lot of resources, there's a lot of documentation, there's a lot of presentations. It started at UC Berkeley. It has had a lot of support. It is a very well-liked product, and this is the community. So there are a lot of contributors in this community. So fundamentally, you might want to say, well, okay, but who's got this in production? Well, a couple of the bigger names that have this in production are Yahoo and Adobe. Okay, they're not small, they're a pretty good size. So the tenure that this project has behind it is reasonably strong now. It became a top-level Apache project in February. It's not in incubator stage anymore. It came out of that. The user base is swelling, and the contributions in the open source community are huge. So Spark, more contributions than Apache Hadoop. That's a pretty big deal in my mind. I tend to think that I'm not very easily impressed when it comes to technology. Technology really has to do something different. It has to show itself to be something that's really lacking or really fix a problem. Just every single little framework that's out there doesn't really do a lot for me. Spark has impressed me beyond any other technology. The next closest kind of falls onto like Mesos and Docker, and they are not really in the same space. So what you really get here with Spark is a unified platform. So I'm going to talk a little bit about Shark. I'm going to talk a little bit about Spark Streaming, very little bit about the machine learning library, MLlib, and then I'm not going to talk at all about GraphX, other than to say GraphX is a graph analytics library. Okay. Facebook, I believe, and you might want to go do your own research on that. I don't remember who it was specifically, but they've loaded 1.5 billion edges and 1.5 billion, roughly, vertices into GraphX and doing analytics with that. And they're doing it very quickly. Underneath those is the Spark execution engine. So the fundamental platform that you will use if you use Spark. You want to use the Spark API, that's where you're looking at. If you want to get into doing streaming or machine learning or graph analytics, those libraries are built. They're separate projects, but they're part of the Spark ecosystem. Much like Hadoop has Zookeeper and Hive and Pig and HDFS, all of these different projects are really Hadoop. right? Hadoop isn't just one little package, one little project. It's the whole ecosystem of projects that are a part of that Apache umbrella. So what they've got coming soon, I believe they've got these things targeted for the 1.0 release. Java 8 closures, lambdas, will be integrated into the code base. So this will bring yet another level of simplified coding to the platform. The Spark SQL, it's not Hive. Okay? So Shark, what Shark brings to the table is that it takes Hive queries, it uses the Hive metastore, and it takes that information and it runs it on the Spark execution engine. I'll explain why it's useful in a minute, but the key separation here, Spark SQL, is not based on Hive. It's taking a SQL language and making it run on the Spark execution platform. But again, Hive is a limited subset of SQL. Spark SQL, I don't know exactly where it's going to net out for how much of SQL it will support, but it will run on the Spark engine. BlinkDB, I actually find to be a rather interesting project. It gives you the ability to load terabytes or petabytes of data, and instead of keeping all the data, it keeps track of samples of data. So if you need to come up with approximations, not everybody needs to do approximations. If you need to come up with approximations, BlinkDB will actually support approximations, and it will come back with a plus or minus percentage of accuracy for you when you do queries and you ask it questions. Is it viable for every problem out there? No. But it has its use cases. It's extremely powerful. Spark has support for this. And then for those people who have a strong interest in R, which I feel very strongly about R, I think it's got a great standing, and I think it's really going to upset SAS in the long term. The Spark R wrapper is going to be, I believe, part of the 1.0 release as well. So from a language support standpoint, this is what we've got. So Spark is predominantly actually written in Scala. Java, Scala, Python, and logistically speaking, Hive because of. So one of the important things to have to understand about Spark is where do you get your data from? Where are you reading it from? If you imagine that you should be able to read data from there, it probably is supported by Spark. So you want to read it from the local file system, you're good. You want to read it from HDFS, you're good. You want to read it from HBase, you're good. It works. If there is an input format for Hadoop, you're good. The machine learning MLlib. So these are the algorithms that are currently supported by it. I will not ever claim to be an expert in any of these algorithms. I will tell you that they are very well documented to explain what they can be used for. The more well-known machine learning library that exists out there is Mahout. So Mahout works on Apache Hadoop, and the primary contributors to Mahout are starting to port those libraries over to Spark. So don't be too surprised if you see that happen rather soon. I can't put a timeline on it. I don't know. I'm not a contributor to Mahout, but it's happening. So, what's the real difference here? It's easy to develop on. The API is very well documented. This is a stolen slide. I won't claim to create this. It's a simple API. You can read through it. I've got URLs in the slide deck, and we will make sure the slide deck is shared later. But you know, if you read this and you think, well, it kind of sounds, you know, like what Pig or Hive really promised for, it kind of does to me as well. But the big bullet point there is under easy to develop is interactive shell. Okay, interactive shell doesn't exist anywhere else that I've seen for MapReduce. It's not there. I will focus on that just a little bit, but
how about run shell?
I'm sorry?
How about pigs? REPL run. Pig has a.
It's not really an interactive shell, so to speak, though, right?
Yeah, I guess you have to output something for it to run a MapReduce job. And in the end, it has to run a MapReduce job.
Yeah, in the example that I'll go over, you'll see the difference of why this is fundamentally different. So, why Spark is fast to run? It has general execution graphs and in-memory storage. So, less code, faster on disk, 100 times faster in memory. You get to pick and choose when you cache things, and you can tell it where to put it if you want to cache it. So you got the opportunity to optimize in different ways. So the big differentiator here is resilient distributed data sets. The link that I have at the bottom here, this is the paper that was written and published by the folks at UC Berkeley that were working on this project. And this gets to the fundamental premise that Spark is built on. And that is fault-tolerant collections. Okay? Simply put, fault-tolerant. I have a cluster of nodes. If I lose a node, the data that's on that node needs to be somewhere else. Okay? If I have a resilient distributed data set, what I actually have is something that I know how it was created, I know what the input sources were for it, I know what transformations were taken on it, and I have it available to use now. You can do transformations on the data sets. You can take actions on the data sets. So think of it like I want to filter this data, and then I want to do a simple case. I just want to do a count, right? How many instances of this word happened on this data? Okay. This is what you can do with the resilient distributed data sets. I think there's somewhere 40 to 50 methods that you can utilize as part of this. So with respect to what you want to do with this data, okay, you've got the choice for where to put it. You get to pick and choose. If you want to cache it, you want to persist it. The benefit is seen disabling the cache, here's your speed. Enabling the cache fully, here's your performance. Here's the graph. So if you don't have enough memory to cache all of your data, right, you're sharing your cluster with others. You don't have the memory for it. Go ahead and balance it out. Feel free to change and tune and tweak your Spark cluster. Make it do what you need to do. Fundamentally, what exists here is the ability to get the performance you need based off of the money and resources you have to throw at it, right? So the default is that it will do memory-only caching. If it has to spill to disk, it will use Cryo as its default serialization format. Reasonably fast, reasonably small serialization format. You have the ability to say, if I'm using this in a web application where I can't wait 30 seconds or 5 seconds for this resilient distributed data set to be reproduced, I need it now, I can say, put it on a second node. So if one node dies, it's already on a second node. You go looking for that data set, it's already there. So this is offering the ability to leverage it in more enterprise-wide application usage, right? So much like HBase, I want fast access to my data. I want to ensure that anything that I'm building to leverage this in an enterprise application is functional, fault-tolerant, highly available. So this is all based on DAGs. Now, in general, you might notice that this image looks a lot like a source control tree. If you were committing code, merging code in, that is, in fact, a directed acyclic graph. So the importance of it is that every one of these arrows within Spark is part of what it takes as an input to create that resilient distributed data set. Spark tracks the inputs. So if you say, this 10 gigabytes of data went into this RDD, you're done. It knows how it was created. If you lose that node with that data in memory, all it has to do is go back to your data set and say, the RDD cache said that this RDD that's no longer available was read from this 10 gigabytes of data. Go reload the RDD. That RDD is managed as part of the metadata of Spark. Spark is highly available, utilizing Zookeeper, just like HBase is. So it matters a great deal with respect to fault tolerance. It's much simpler than most other solutions I've seen with respect to fault tolerance. Everybody wants to make sure you've got your data in enough places that it's always readily available. And at the end of the day, this is a key underpinning of why Spark works, and it works simply. So this explains the lineage. Okay? Again, back to the arrows I mentioned on the last picture. When I define and I pass it this function from this API, that's what it's holding on to. Okay? The transformations and the actions that you take are what are important to Spark to maintain the high level of fault tolerance that's required to meet the demands of this platform. The RDDs are a pretty impressive concept. If you read that paper, the PDF link that I had a few slides back, if you pull that down and you want to understand more, read the paper. It goes through very well, describes it very well for people who aren't necessarily focusing on that as their day-to-day job. The streaming component with grep and word count, this comparison here was with 100 record, or 100 byte record and 1,000 byte record. Very fast when compared to Storm. Now, why compare to Storm? Well, I mean, let's be honest. Storm is one of the few successful streaming platforms that are out in the marketplace right now. Spark blows it over, just smokes it. The 670,000 records per second per node is pretty darn impressive. If you've got streaming use cases, you need to consider Spark. Storm is still great. Storm is pretty well documented. There's lots of use cases out there. Spark for streaming is probably going to take Storm over in the next year or two, in my guess. There's no secret sauce here, but I think as people start to see the simplicity here, that it'll start catching on. And I would highly suggest anyone that needs to do streaming give it a consideration. So, as I mentioned a little bit ago, the interactive shell. So, let's walk through the life cycle of a MapReduce job. I write code, Java MapReduce, I compile it. If I write a pig script or Hive, I write that, I put it on the cluster, I deploy it, I execute the job, it reads the inputs off of disk, okay, so however much data that is, streams it all in, does the work, generates all the MapReduce jobs, the output pops out, you go look at the output. Okay? This is what everybody has considered near real-time analytics. Anyone who talks about Hadoop MapReduce will always say near real-time analytics, because it's not real-time, because it's asynchronous, you're waiting. Right? You kick it off, you go back later and check and see what the output was. Well, from a data analytics perspective, the benefit is going to come from reducing the iteration cycle. Right? The less time spent asking the questions and waiting for the same work to happen over and over, the better off you're going to be, the quicker you're going to get your answers, the happier you're going to be. Show of hands. How many people get annoyed when a web page takes more than 5 seconds to load? So, how is it people are tolerant of MapReduce jobs that take 6, 7, 8, 10, 20, 50 minutes to run? It's baffling to me because people are so impatient with the web browser, but yet they're okay to wait with MapReduce. Well, fundamentally, they don't have a choice, right? They're forced into it. It's out of your hands. Well, this, in my mind, this is the big deal. This, to me, is the game changer. An interactive shell that I type in and say, load this data from HDFS. 10 gigs, 100 gigs, whatever. I say, cache. Load it into memory. Boom, it sits there. The shell is waiting for me to run my next command. My data is sitting in memory. I want to transform that data 10 different ways. Type the command and run it. You want to filter it. Each one of those filters generates another resilient distributed data set. Do you want to cache those for further use? Or do you want to do something with them in line? Do you maybe want to do a count? Right? The very simple examples that everybody shows us. It's just sitting there waiting for you to ask it questions. This doesn't exist in MapReduce. It's not there. So to get real-time feedback is, again, in my mind, this is the game changer. From within this interactive shell, you can import the machine learning library as well. You can import the Spark streaming library. So any of those libraries that are available, you can import here, and you can type it and you can use them. So you can use them in combination with the APIs that are part of the standard Spark execution engine. That is a big deal. I formerly worked at a digital advertising company, and for about 2 to 3 years, I kept trying to get the folks in our decision sciences team to focus a little more time on utilizing Hadoop to start asking all their questions. They started using R, they were pulling data out of the large data warehouse, whose name I won't mention, and they recently started hitting really big, heavy limits, and their costs to expand due to data size for that data warehouse are astronomical. So one of the guys that I used to work with sent me a message the other day and said, hey, just wanted to let you know, we're starting to evaluate Spark. So I know, you tried telling us this 2 years ago, but we're finally starting to look at something. Anything is better than nothing. And quite honestly, the leap that this gives from a simplistic standpoint is a big, big deal. If there is no other takeaway for anyone here on Spark, then there's an interactive shell that I can run my queries and get answers in the terminal. That's good. So, if you have pre-existing MapReduce, what do? Well, if you have Java MapReduce, bummer. If you want to run them on Spark, you're going to have to figure out how to port them over. This is not saying all MapReduce should become Spark. That's not what this is. This is saying if you've got things that fall into this model, you should probably consider moving them over to a platform that's going to be faster and easier to maintain. MapReduce has its place. I think Jim will be your guy. It's going to continue to live. It's going to be there. And it's still going to serve its purpose in large batch analytic jobs that just need to be very hands-off. Yeah?
When you say port over the Java to what?
To Java API for Spark or Scala code or Python. So if you do, remember that part of what drives the community is sharing your learnings from doing this. So there could be things that you uncover when you're trying to figure out how to get over Spark. Go out on the board, share the information. Make sure that people understand, hey, I ran into this roadblock. I couldn't get past this. Maybe somebody else knows, maybe they don't. Maybe when someone else has the same problem, they see that other people have the problem, and they've got someone to talk to. Pig scripts. Well, you can port them over. The API for Spark it's kind of similar to Pig. It's much more similar to Scalding and or Scrunch. But you could also try Spork. So Spork is the Pig Spark integration I've got some links at the end that show where you can go find information on it. It is not in final stage yet. The Databricks guys are working on coming up with a solution to help make it so that Pig scripts can just run on Spark, which would, again, make it simple for everybody just to get on the Spark platform. Much like with Hive, just put your query over on Spark and you're done. So that takes us into Shark. So if it works with Hive, it works on Spark. I'm not trying to oversimplify. It just works. There's been a lot of time going to Shark. Shark takes a lot of time for maintenance. So when Spark SQL comes about, it'll be one of these where there will be a ramp up for Spark SQL, and there'll be a ramp down for Shark. And some period of time, Shark will disappear. So it's 10 to 100 times faster than just running Hive as general MapReduce jobs. So it's a big deal. And again, if this were the only part of Spark, it might be pretty difficult to explain why Spark should be considered. But from more of an arsenal perspective, this is one very strong facet of many other strong pieces that can be leveraged. Right? If Shark was the only thing I was telling you about, you might say, yeah, it's good if I did a lot of Hive stuff, but not everybody does a lot of Hive stuff. So if you have a little Hive and a little Java MapReduce and a little of this and a little of that, it'll just make Hive faster. Questions? Yes?
Yeah, what about Spark-specific configurations? Like, for example, you know, with Hive, it seems like it ought to be easy. Oh yeah, it's like a SQL-like thing. But then you have all these, you have these set commands that you can start tweaking all the MapReduce parameters, and then special Hive parameters. And you can spend a lot of time just on that. So, if I have been doing.
And thus Hive is not perfect, is it?
No, it's not. So is there anything like that you have to tweak in Spark?
You know, there are a lot of tuning parameters for Shark. I can't even begin to explain what they are because I don't have the in-depth knowledge of Shark. It is very well documented though, at this point. About 2 years ago, about a year and a half ago, the documentation was pretty sparse. It seems pretty strong at this point. But yeah, I mean, it really goes to me personally. I've always been much more a fan of Pig. I feel like Pig has always been a little easier to tune and make it work the way you want to. Hive is kind of wannabe SQL, and it works. Is it always the most efficient? No. Is it always easy to make it do what you want? Certainly not. But it works. So it doesn't just solve your problem.
What's the use case for this stuff?
For Shark?
No, SQL over Spark.
Well, Shark, this is Shark.
No, I mean, what do you use it for? I guess is my
Well, if you have other Hive MapReduce jobs already written, it runs it on Spark. So you pick up the speed of it leveraging in-memory utilization.
So you're talking about, like, I'm just trying to boil it down to people who actually, like, because a lot of our guys are trying to figure out, like, where does it go in an organization? Are you thinking, is this like a product that you would do for like a read-only data warehouse offload solution? What kind of application, or what is it you run on this?
You know, this is one of
it
those
all
where
just data science, where we say, here's some data, go play with it, and you use this tool?
well, most people that I know using Hive are doing some form of ETL with it. So here's a bunch of logs, different types of logs, join them together this way, output this, and now I'm happy to look at it in this other form. I've gleaned some type of information out of it. I've aggregated it in some certain way. It could be data analytics driven. It could just be ETL driven. From a general MapReduce standpoint, Hive is just another language of MapReduce. So anything you could solve with MapReduce, you could solve with Hive within the limitations of what the language allows. So I personally have never once advocated Hive. But if you have Hive in your organization, Shark makes it so you don't have to go rewrite it. Make it faster, it just works.
So I recently saw a blog where some Yahoo recently tried Hive on Tez or Yarn, one of those, and claims that it's faster than Shark.
I have not seen anything that shows Tez is any faster than Spark with Shark on it.
Oh, sorry, it is. They did vectorization of their aggregations, which really helped them. So they have some places where they are actually faster.
Okay.
Just to be fair, it's variable. It hops back and forth, but Tez has done a ton of work on being able to compute lots of aggregations really quickly. And it's pretty impressive. They've done some cool stuff.
I guess Tez brings that in-memory component to MapReduce where you don't have to spill to disk all the time, so it's probably kind of similar, but maybe
only-
not.
But the limitation is within Hive, right? So whatever the Hive language allows you to do, that's what you can run on Tez, right?
Does Shark let you do more than that?
No. So and thus, this is kind of the where the equivalence is drawn. Is Tez is equivalent to Shark.
Okay.
So
Oh,
the
yeah.
Spark execution engine is a general purpose engine. All of these libraries are available for it. Shark is one way to run Hive.
I
as
think
a
you can run
non-MapReduce.
more than Hive with Tez. Like I've seen people run like big scripts and I don't know what
I've
else.
never seen anything. That wasn't part of their original charter for it, so I'm not saying that there isn't. I've not seen it. Yeah, so Tez, the intention of Tez was to make Hive faster.
Yeah.
So as of this point in time, Hortonworks puts pretty much all their resources into Tez. They don't really support Spark at this point. So they're kind of competing. They're not they're not being nice to the other open source team so much. Not to say that they're being mean, but Tez is their baby.
So what is the max limit that RDT can store?
How much memory do you have?
So can it handle the petabytes of data?
Do you have petabytes of memory?
Is there any limit?
Well, how much? The data you can cache in memory is going to be limited by your memory you make available to Spark. So can you do queries over petabytes of data with Spark? Absolutely. Do you have a cluster that can support petabytes of data? Oh, okay. More fundamental. All right. So a couple examples. Everybody's seen this. It's pretty straightforward. So in Java, to do word count, MapReduce, it's going to be about 15 lines of code. That's not a lot, but its word count is pretty simple. Java and Spark, it's about 7 lines. So you get rid of the MapReduce overhead, cuts the code in half. All right, not bad. Scala and Python, 4 lines of code. If you go do a word count in the Scalding framework, I think you'll also see about 4 lines of code for it. It's pretty simple. If you want to do word count in the interactive shell, the very first line, get rid of it. The interactive shell gives you access to the Spark context as soon as it launches. So the first line gives you the Spark context here. It's how you get association to it. The last line, instead of saving it to output, which would be more of a batch mode, just tell it to do a count right in line. It will deliver the response to you in the shell. Java 8, when that functionality is here, looks a lot alike. A little more verbose because it's Java, but still 4 lines, fundamentally the same. And that functionality is coming as part of their 1.0 release.
Is Java 8 required?
No. Java 8 is not even supported right now with Spark.
Oh, okay.
In the 1.0 release, it will be. If you want to utilize the Java 8 functionality, you will, of course, have to run a Java 8 runtime. So this is one of the examples that actually comes stock with Spark. So this code is part of the distribution. It's for doing a network word count, so streaming. If you want the data streaming into your context, it's going to count it. So it's, again, another example of how simple it really is to utilize these libraries that are provided here. Looks a lot like the last slide, right? The APIs are pretty well standardized across the streaming library and the non-streaming library. So it's going to be pretty easy for most people to start getting moving with Spark. and say, oh, you know what, I want to try this with the streaming library because I want to start pulling some data off a network socket and just see what it does. APIs are darn near identical for every single case that I looked at. I say darn near identical because I'm not going to be the one to say that everything is 100% between the libraries, but they were pretty close. Yeah.
On the previous slide, should a takeaway be that we should go with Spark over Storm on streaming?
Oh, for the streaming?
Yeah.
Oh, personally, yeah.
So I shouldn't even consider Storm anymore.
I think if you look at Storm, the concepts that you'll pick up out of Storm for streaming capabilities are going to all be covered with Spark, and it's going to be faster. Yeah.
I mean, I think they're kind of slightly different use cases in the sense that Storm's more about low latency, and Spark's more about streaming high throughput because it's like a micro batch kind of thing. It's
Right.
not the same.
It does in fact do micro batches, but you can specify what those batches are. So the question becomes, what's your batch size? When you say real time, if you, let's just hypothetically say you were monitoring a network, right? You've got packets coming in, your streaming context is handling that. How fast can you actually make a decision off it, or how fast can it respond, right? What's the window of service time that it can react to something? Typically, it's not just one record that triggers something, right? It's a series of records that trigger something. So you can define those batch sizes for the window operations that Spark is going to utilize, however you need to for your use case. So if you say, I have 1 millisecond windows, you can do that. Do you need to make decisions on less than a 1 millisecond scale? I don't know how fine a...
But I guess the lower you go on your time scale, they'll probably start performing this similar layout thing. So Storm and Spark.
Well, even if that's the case, that's all the more reason to use Spark, because
Yeah, I'm not saying one or the
because
other.
you've literally identified that in the worst case scenario, it's equal to Storm.
Yeah, I mean.
So in the best case scenarios, which are going to be most scenarios, most real-time response systems for streaming purposes don't need any more fidelity than a millisecond, most. I'm not saying all, but it's configurable. You can change those window times for the batching.
I like Spark.
So again, this example is really just to show how simple it is to do streaming with Spark. And again, just another library, just another component of Spark. So when it comes time to deploy Spark, the important notes. I have Spark. What do I do with it? How do I manage it? Well, you can deploy it in standalone mode. It comes with scripts for you to be able to launch it in EC2 if you're using EC2 for your cluster. You can do Yarn, and you can do Mesos. So standalone mode, you're putting it out there, you're managing it, it's running on the same nodes as your HDFS for your Hadoop cluster, go. If you put it in Yarn mode, it will integrate and Yarn can manage the resources for it. If you want to take a step forward in managing your data center, okay, I don't think there's a lot of people out there who know what Mesos is. I don't think there's a lot of people out there who understand what Mesos can actually deliver. But look forward, I don't know, 6 months, a year, 18 months, Mesos can manage the entire data center. It can manage the resource utilization for all servers, not just what is Hadoop processes. So my simple example for this is you have Hadoop in your data center. You have your custom applications, or let's just use Apache Web Server as an example. Okay? You've got your Apache Web Server generating logs. If you wanted to put these two applications on the same server, most people don't really do that, but you could. Mesos can manage the two of those. So Mesos can manage the resource utilization of Apache Web Server and Apache Hadoop and Spark and anything else you have running on that box. So if you want to see a larger utilization of your resources, the support is already there for Mesos. So again, I'm not telling you any one of these is right or wrong. You use whatever you need to in your use case. They all work. They're all functional. My little prediction note for everybody, for what it's worth, whether you care about it or not, is Mesos has a tremendous amount of value, and the functional integration that you get into your data center or into your cluster is going to be a far greater thing than running any other mode. So, much like MapReduce, you have to learn what you can do with the technology. Okay? This is 101, right? You can say, wow, this is awesome. Wow, this really doesn't fit my use cases, whatever it may be. You've still got, if you want to get into this foray, you start using it, you're going to have to get into the documentation, you're going to have to get into the forums, right? MapReduce 4 or 5 years ago was the same way. What do I tweak to get this performance out of it? There are a lot of things that can be tweaked and tuned for Spark as well. So, take your time, figure it out. I think that most people will reap the benefits in different ways, but pretty quickly. Because again, I think the documentation's pretty good. If you take use cases you already have and start playing around with it, I think you will find adoption fairly quickly. And again, to get the most out of it, you've got to go through those tuning exercises, much like Hive, the fact that there's a lot of parameters you can set to make it work the way you want to. You've got to take a look at the tuning parameters. And you know, the things that you learn from these, again, this is where you can really contribute back to the community, right? People who haven't used Spark yet. There's people at all different levels that have been using this technology and many others. Your contributions back to the community, sharing your experiences, are the value that you give back to everybody else in the user group, right? All the other user groups that are participating and trying to contribute back, remember, share, learn. So these are some links for the configuration information. The Pig on Spark, or Spork, project that's out there, there's quite a few links here because there's a lot out there right now. And again, just to reiterate, it's not proven out. Some of the things will just work. So if you are following pretty much straight group buys and, you know, here's my loader and here's my writer from Pig, you may just have your stuff work with the Spork project in the state that it's in right now. So at the bottom, the Databricks website, a very good place to kind of get the latest big news on Spark. The one below it is a open source blog, basically kind of keeping track of what's going on in Spark, the libraries, the contributions that are being made to it. And then, for anyone who cares, Spark Summit. I think this is their second or third Spark Summit. Does anybody know?
It's at least the second. They had one last year.
Yeah, they had one last year. So that is coming up. And again, you know, from my perspective, just to make sure everybody knows, this is part of the open source community. And at the end of the day, these are the things that are helping drive companies and people's education to really become, you know, kind of next level, right? These are people who aren't just sitting out there saying, I'm going to make money with this, right? These are people who are putting their time into helping everybody. So, you know, keep that in mind. And, you know, I can't stress it enough that, you know, participating in the community is what's really driving this community.
So how do you extend Spark? Like, I guess, is it just Scala code, or for Pig you write UDF, right? So is there something similar to doing RDDs for Spark, or it's just Scala code?
It's the beauty is Scala and Java are both functional in nature as of Java 8, and Scala has been. So it's part of what actually has made, in my opinion, Scalding and Scrunch and Scooby successful as framework or DSLs, because they've given you the ability to extend them in your code base, right? You don't have to leave your Pig script or your Hive query and go write some code somewhere else and make sure it's deployed out to the cluster. You write it and you deploy it with it.
Yeah, but how would you reuse some of that? Like, let's say I wrote some Scala code that works in this program. I also have something very similar in my next program. Can you?
Well, it's a program. Put it in a separate file and create a separate package for it, right? You're talking about shared code. It's just another library at that point. If you create functions that do your special sauce job, put it in the library and then just import it in your code.
Yeah, it's good.
So in my mind, this is where the Hadoop world is really moving, because it brings the simplicity. it's really, really simple to get what you need to do in there. You can write your functions in line. Like, don't go anywhere else. It's a one-stop shop. Yeah.
I had a comment, which is, since you mentioned Crunch, I'll just add that Crunch now has a Spark pipeline, so you can take your Crunch script that, or Crunch code that you've written that runs against Hadoop MapReduce, change one line, instead of saying new MR pipeline, you say new Spark pipeline, and then you can run it on Spark. So this is kind of what you're talking about, being able, with Pig, with Spork, being able to take your existing script and sort of port it over to run on top of Spark. You can do that with Crunch now.
I'd be interested to see what they've actually got with respect to support of the APIs and what all will work.
It's relatively new. I'd say it's been around for 4 months maybe.
Okay.
I can't say how widely implemented it is, but it's there.
Yeah, I mean, Crunch, when I first read about Crunch, I personally thought, it's too bad this didn't get out before cascading. But, cascading got its foothold, and Crunch is pretty darn good. They do this, effectively the same thing in very different ways. So, anyone else have any questions?
So if you wanted to get information from from a source that isn't one of the supported sources, so if you're not grabbing it off of, like, if you have to reach out to a JDBC connector, or if you want to get something off of Solar, how would you go about creating that sort of new front end? Or is there
How to
an
basically,
extension there? Yeah.
how to get basically a different data source.
Yeah.
Quite honestly, I would say you would want to probably go open a ticket in the issue tracking system for Apache Spark, or go search and see if there's already a ticket there, because there may very well be, to say, can it already source this? The documented sources that I had in here, they're listed on the website. What others could be requested, they may be working on some, I'm not sure.
Okay.
But I would say check the Apache Spark issue tracking system and see what's out there. And otherwise, you can submit one.
But generally, that isn't a, I really need to get a JDBC data source, or I really need to get a Solar data source. I'm going to gin that up on my own.
Yeah, well, absolutely. It's open source.
Well, yeah, but I mean, it's relatively simple to do something like that with like a Storm, because you're just creating the package.
Can you speak up a little bit? 'Cause I can't hear you.
Sorry, I'm trying to figure out how you would go about getting a data source that isn't one of the 4 enumerated types. So if you want to get something off of, say, Solar or JDBC, how do you?
They already have a JDBC RDD, so you can probably take it off the list. Solar, they don't. So they already have something for JDBC, so I guess they figured everybody would need to get to the database, to load some ref data or whatever.
So one thing about Spark, should you write input and output formats, like you do in MapReduce?
It supports all of the Hadoop input formats.
But even for some other data type that you want to, or some other source of data that's not something that you guys put out, but you can write that
Yeah.
as a word in Spark.
Yeah. If you can do it in, if you can read data or write data with Hadoop input and output formats, you can use those in Spark.
Just one caveat, it's a read-only system. So if you're using HBase or something that's changing, your RDD a lot of times isn't smart enough to understand the data I just submitted to HBase for input-output format no longer is valid.
The
So
data
that
that
makes sense. RDDs are not changeable data sets, they're immutable.
That's right.
You create them. So you're really looking at sitting on a data source that is not changing.
Right, so if you
That
look
makes
at
sense.
Scala collections as an example, all collections in Scala are final. So immutable, not changeable, which for most people's use cases doing data analytics, things of that nature, probably not a big deal. If you have a use case where you say, well, I want my RDD to be changing, probably not the explicit right use case.
So in terms of the APIs, would you recommend picking up Scala to work on this as opposed to using the Java API?
If you're not comfortable in Scala, I would say, maybe start looking at the APIs and maybe just hold out for the Java 8 lambdas to be there, because that gives you a functional implementation. So if you don't want to go through the time of learning Scala, Java 8's not far out.
Python's the other alternative if you're comfortable in that. You can use PySpark. I like the Java.
Any other questions? Yeah.
I might just be having trouble wrapping my head around some of the stuff because I'm not a regular Hadoop user. But you said several times during your presentation that what makes Spark fast is the execution engine.
Right.
But if you can write your jobs in Scala or Python or R, it seems like those interpreters would be what's actually doing the execution. So how does Spark make it faster?
Spark is written in Scala. Right? So Spark is just written in another language. The fact that it's caching data.
Oh, I see. It's what it's accelerating is getting the data out of wherever it's coming from and putting it into the interpreter that's going to do the computations.
Actually, the thing that makes it really special, I don't know if we talked on it enough, but it has an actor framework with a package called ACA.
Yeah.
And Jim, if you want to talk to it, go ahead. I think to his point about what makes it fast, I'll let you go ahead and talk to it, but
Yeah, so the ACA framework, for those who aren't familiar, basically, has anybody here ever heard of Erlang? Okay, so Erlang was probably most notable for the actor framework. Well, ACA framework was literally implemented based on the Erlang actor framework. So it was implemented in Scala. It's available for Java and for Scala. It gives you a mechanism for communication between your actors. Basically, the workers that you've got, you have a communication model, and if they die, they're monitored, they come back up. And so this is part of what makes that framework special. If you have a highly available system that you want to build, ACA is a great thing to consider from a model perspective to build and manage that. Was there something, or?
No, I would say more than, so the thing that sucks about MapReduce, let's say you have 6 steps you want to run, right? And you're going to have different aggregation levels. You run it, it runs all to disk, completely finishes one step, then the next step kicks in. And you run it completely until it finishes, stops, like an Uzi utility pipeline where people build those. And it finishes, you run the next step, right? So it's very much what we call barrier, or it doesn't have a pipeline approach. ACA supplies a pipeline. What does that mean? When you're done with step 1, you can proceed to step 2. Where MapReduce has a defined barrier that says you wait while you're writing that data before you proceed to the next. The actor framework is what's making it interesting for companies like Splice, the database companies. Because if you think of like how a Vertica or DB2 or Oracle works, they have similar actor frameworks where as you go along the pipeline, you may have grouped some data and then you're joining some data later. The data moves along those pipelines. So that's why Spark is of interest to companies like Splice, but also I think why you're seeing, as Jim talked about, this adoption in the thing. But the actor framework is one of to me, that's the thing that gets me perked up about Spark. That's extremely powerful in the sense if you have multiple steps where you're doing different aggregation levels, you can pipeline, which is really powerful compared to MapReduce.
Yeah, and I really completely overlooked it. When I showed that picture of the source control tree, that's ultimately the benefit of the directed acyclic graph, is that those starting points literally could be 3 different data sets, and that could be the process each one of them goes through to get to the end point. And so they get to work until it's ready for them to merge in to what the next one needs to merge into. So you get the benefit of those separate paths occurring at the same time.
But again, if it is a distributed and we are talking about actor pattern, we I understand active pattern is you can spin up different processes and it will be alive and keep answering the question until it dies, you spin it up again. So it's fairly asynchronous.
Well, that's the key right there, is that it's asynchronous process. So while the high availability is the main focus of what Erlang originally designed, you can hack on to the design to realize that you can proceed with lower latency by processing through the acyclic graph. And you get high availability and low latency. So who doesn't want to? That's one.
And all this research actually, and I don't know if the Microsoft people mentioned it when they were here, it came out of their initial attempt at big data, really influenced a lot of the guys that were thinking about DAGs and how you would do that. And I forget the name, Tom, or Jim, you may know, Microsoft had an initial product that, Dryad, that's the name of the product, that was based on DAGs, very cool technology, and it was really based on these extremely powerful, so it's neat to see Spark kind of take off, and you realize, Dryad got really knocked. People said, oh, how is this for, blah, blah, blah. But actually their technology, a lot of their ideas are in this type of approach. So it's a neat, but as Scott said, yeah, it's really, the actor framework is extremely powerful.
Where actor resides? Is it on the individual node?
Yes, it's on, so the actors, so it's got basically a similar framework as Hadoop. You have masters that then, farm out these processes, and the actors do reside on those. But they can pass between each other, and that's something that, to be honest, the MapReduce framework does not have. That would be a thing that makes it kind of MapReduce plus in some sense. And then there's obviously the in-memory component that also makes it interesting if your data sets aren't changing.
Now everybody here knows how much John likes Spark as well. Now everybody else here knows how much you like Spark now too.
I know a little bit about it.
Anybody have any other questions?
So what's the memory distribution, what's the actor, and how it works? I mean, we know MapReduce. So mappers, get it, produce it, shuffle it, and do it. Everything happens on this node. What does Spark in you? So let's say,
Well,
take a
think
simple
of-
example.
Think of data sitting over here, and you've got, say, data already cached over here, right? They're going to talk to each other, pass the data over, so that it can operate quickly, right? It doesn't repeat work.
Where it can.
Spark,
Everywhere?
wherever it needs to cache the data. It doesn't cache everywhere. It reduces redundancy. Okay, so you don't have data, you don't take a gig of data and replicate it on every server. You don't replicate it on 3 or 4 other servers. It's on one. So when another server needs it, it's going to continue to live. It's going to talk to the other server, get its data, pull it back. It's going to do its work. It's going to share the work appropriately.
By the way, that's a huge deal. Think about it, how many times you have to replicate data to make sure it's reliable. And what he's saying is basically, look, you write it once or in memory once, and if something goes south, great, you build it from lineage. But if it doesn't, it's a heck of a performance.
Yeah, and there's a lot of information out there that basically shows that when you lose a node in your cluster that has data, and so they'll have charts out there, they're probably on the Apache Spark site, that you can see where it'll show iteration over iteration, reasonably similar time processing every single iteration, and then they kill a node. The time to recover the data on that node is 2, 3, 4 seconds in most cases. So it's very quick to reproduce these RDDs that are sitting there that are part of this, doing it over and over and over and over. I've lost something. The resiliency, the fault tolerance, it's quickly back. If your web application or whatever you're using to leverage that data needs higher fault tolerance, that's where you could say, put it on a second node in memory, right? You need that additional resiliency because you don't want to deal with even 2, 3, 4, 5 seconds of rebuild time.
Yeah, but how about the maintenance side?
Maintenance time in what do you mean?
You put something in memory, but you need to keep it up to date. If I load other things in it, I still won't do it.
Yeah. Right, there's a lineage there. So it's literally, I go from here to here to here to here. If I want to change this, I'm really creating an entire new lineage.
But
a lot of the cool stuff to happen, you need to have enough memory, right? So Spark, is it a good fit for a certain type of problem, which probably are like not petabytes, but more like something that can fit in?
Well, it keeps stuff in memory as long as the context lives. So when you kill your context, your memory's gone. So it depends on what your use case is. You know, if you're
but
just
still,
doing one off,
Yeah, I mean, at the end of the day, like, given that screen only has so much memory, right?
yeah. Yeah, there's TTLs for RDBs.